Hi, welcome to my Unreal Engine for You tutorials. I am Gustavo Reis and I'm an Unreal Engine authorized instructor. So for today, we are going to cover C++ programming language in Unreal Engine. The learning objectives for this video and this session is to understand when to use C++ or either use blueprints because there are different situations and different cases which one suits best. There are situations that C++ is the option. There are some other ways that you should go definitely for blueprints. So understand when to use one or another. Know the professional workflow, so using C++ and then blueprints and how they couple together. Create and compile your first collectible class, in this case a C++ actor, which is a collectible. We're going to have a coin, and implement basic collision and events. So why C++ in Unreal? The most important thing is performance, because C++ is compiled, so it's compiled to machine code. So basically you have native speed. So better than this is almost impossible. Then you have direct access to memory management, so you control everything. You have memory control. And for me, the better thing of all is the full engine access, because you in C++ you have complete access to the Unreal API, which does not happen with blueprints. There are some things that you are not allowed to do and you cannot totally do in blueprints. Otherwise, by using C++, you can extend any part of the Unreal Engine and you can access to any part of the API and do whatever we want with it. So that's the thing to do. So, when to choose C++? The thing is that despite you having access to everything on C++, to the Unreal Engine API, there are some things that blueprints is the proper way to do, especially when related with cosmetics like particles, materials, textures, and stuff like that. All the cosmetic things and visual feedback, audio, you should stick to blueprints. I will choose C++, especially for performance critical systems like physics calculations, heavy stuff, AI agents, or if you need to have some complex algorithms and data structures, or foundation systems that multiple assets will use. That's the way to go. You should couple and for C++. And when you go for C++, the professional workflow, so you might ask, so what is the ideal workflow? What is the professional workflow? So the industry standard is to use C++ as a base class, and then you create a blueprint child that extends that C++ class, and this way basically what you have is all the gameplay logic in C++ and all the visual assets in the blueprint children. So this way, all the gameplay code is hidden on the C++ class, and you decide on that C++ class what is exposed to the level designers and artists, so they can tweak and tune and they don't mess with the code because the code is not there. So they cannot accidentally delete any blueprint node and break up anything. So they just need to select and define what is the static mesh, or what is the material, what is the texture, or what is the sound effect or the particle effect. That's it. So by example, in this case, we have here a class, a collectible, okay, a collectible class that has a property, point value. I'm exposing this property to the blueprint. So if you have a blueprint class that inherits this actor, this point value will appear on the collectibles, on the detail panels on the collectible section, and the users there can edit the value, can edit default value, can change it, can do whatever they want. Nevertheless, they cannot mess with the code, only have access to this to fine tune and change the value for each instance, for example. And another thing is you can have this blueprint implementable event, so you can have you can define functions on C++ and say that, okay, this function is going to be a blueprint event. So when you call this function, you are triggering an event on the blueprint side that the users can define that event for, let's say, firing particles or sparks when you collect something or play a sound effect, whatever. So that's the thing. So basically, gameplay, C++, cosmetic stuff, visual feedback, sound, blueprints. So basically the workflow is first you write the C++ class with all your gameplay logic, and then you create a blueprint child that inherits from your C++ class. Then on that blueprint you can specify what are the meshes, the particles, the sounds, and basically that's the blueprint that you place in the level. So then you drag your blueprint class onto the level, and that's it. Since the blueprint inherits all the C++ code, all the gameplay code is still there, but it works, and we will see that right now. I'm going to show you how to create a simple class, place it on the level as a blueprint, and how the C++ and blueprints couple together. So we will see that in a moment. But first, let me explain one last concept. Let me introduce the big four. So basically, when you are creating a C++ class like this one, you should use this uClass macro to expose this class to Unreal Reflection System. So now Unreal Editor acknowledges and has knows that this collectible class exists. It's an actor, so you can create a blueprint that inherits from it. And in this case, I'm saying that I have a health property. So the U property is a macro that specifies and makes this variable visible to editors and to blueprints. So the people on the blueprint world can change this default value or tweak this value. The U function exposes these functions to blueprints. So basically this take damage now is a function that you can call on the blueprint side. And basically, and finally, this generated body is a macro that generates boilerplate code. So this class can have garbage collect and a reflection system and all these things required by Unreal Engine and are automatically generated by this macro. So you don't have to work with it. So let's create our first C++ actor. How can we do this? Basically, you just go add new C++ class, we are going to name this collectible, and then we will see that we can compile the code, and then we will get collectible.h, collectible.cpp, so the other file, the implementation. I'm going to show you everything right now. So if we go to Unreal Engine, I have this third-person example project, so it's a project that is totally working. It's a C++ project. So if I go to Visual Studio here, let me just make this a little bit smaller. So here, when you create a project in C++ project in Unreal, basically you have a solution on Visual Studio, and this solution has two projects. The first one is it's the Unreal Engine itself with the entire source code, where you can extend, you can see the code, whatever. I'm going to show you the internal code on the next video session, by the way. And then you have the name, the second project is the name of your Unreal project. In this case, it's named third person, where you have here already some files like the third person character.h. This is the header file of my third person character with all the functions and things. And then we have the third person character CPP, which is the source file. Basically here you are implementing the source code. So we are implementing the code of the functions that you declared in header file. So in the third person character.h. So this is a C++ class that was set up on a blueprint. So if you go to Content Drawer here, third person blueprints, I have this third person character that inherits from my character class, so my C++ class, and it's up for the people here to specify, because this was exposed on C++ to the blueprint world, what is the skeletal mesh that you want, what is the materials, the animation blueprint. So So basically this blueprint is just for you to set up all the visual and cosmetic things. The other things you are not allowed to do. If you want to do some changes, you need to know C++ because it says here you need to edit C++ because all those things are protected and defined here on the C++ character. As you can see here, the spring arm component, the camera component, and all those things. So if we want to create our own class, our own actor, there are several ways to do. The first one is go to Tools, New Class, or you can go here on Content Drawer, My Classes, Third Person. Here you have all the C++ classes of your project, and you can right click here and say New C++ Class. I'm going just for the first one, the first way that I've shown you. Just click New C++ Class, it compiles. Oh, and for you to see and make sure that this is a C++ project, I can click here on this button, compile button, and you will see now the code is being compiled. Everything works okay. Let me push my face a little bit upward so you can see the output of compiled successfully. Let us try this again. As you can see, live coding succeeded. So now everything is in place. So let's say Tools, New Class. I want an actor class, so there it is, and I'm going to name this class Collectible. That's it. Create class, and now by creating the class, it starts adding code to the project. It's starting to compile everything, as you can see here. Let me push my head a little bit up. Now, as you can see, it's compiling, changes for live coding, it's performing live coding, so it generates the new class. Now, live coding succeeded. Since this succeeded, now I can place my face downwards again. Now, if I go to Visual Studio, it warns me that, okay, my project has been changed externally because Unreal created some new files like the collectible header and source file. I just need to click reload all, and now that's it. You will see now that on my right I have my collectible.h, so my collectible is an actor. It's a collectible. You already have declared here the begin play and the tick function. So if I go to the collectible source file, you have here, okay, the constructor. The constructor enables tick by default, but if you want, you can disable the tick function by doing this. Now, even if you have the function here, the tick will not work, but I will maintain this true because we are going to use the tick function since this is the first C++ class. Then we will, on the next video, we will use timers instead of using the tick function. And yeah, basically that's it. That's the way to do things. Now, if we go back to our presentation, so you have the collectible H, the collectible CPP, we compile. Now let's dive into our header class. So basically we have this. I can also go here and on my collectible.h strictly say, okay, this is abstract, so you cannot instantiate this class on Unreal Engine, not place the class on the level editor, just the blueprints that inherit from this one. And now I'm going to add two components and these properties. So basically I'm just going here, place them over there, and now I'm going to use forward naming using uSphere component. So and class, this is forward declaration, static mesh component. Basically I'm saying, okay, on this header file, on the source file, I'm going to define what this and include these things. Right now what we have here, let me show you. So basically I created two components on my collectible. So it's a collision sphere that will collide with the character, so the character can pick up the collectibles, in this case this collectible. My collectible will have a visual representation, which is a mesh, and basically these two properties are visible anywhere, so you can visualize them on Unreal Editor, but they are blueprint read only, so the user cannot accidentally delete those and break up everything. So this way he will not accidentally delete my sphere component or my static mesh. Both are on the category components, and this meta allow private access equals true specifies that although all these properties are private, you can have access and see what's happening and set up their default values on blueprint side. So that's the allow private access true for. Since the collectible has some point value, we have here this property. This property is edit anywhere and blueprint read write. So the level designers or someone that uses a blueprint class that extends this collectible actor to tweak the point value, and also if they want they can tweak the rotation speed, because this will be some collectible that is spinning, so, and this is the rotation speed. Moving back to our presentation, we have the tick function, and protected we have also this function, which is a function that will be called when our collision sphere gets overlapped by the character. So the player character, when collides with our collectible, will collect it, so we'll pick it up. So basically that's the function that will handle the collision. So I can save everything and now go to my collectible.cpp, implement this function, and set up some things in the constructor of the collectible actor class. So if we go back to our presentation, the implementation of our collectible class, the first thing we need to do is to include those header files, so we can work with the static mesh, the sphere component, and even the character, to make sure that it was the character that collided with our collection sphere. And now I'm going to copy this simple code here that I will explain on Visual Studio. So copy all this my code here. Okay, now on Visual Studio I'm going to place the code here, and now I'm going to explain. So basically I'm creating my collision component is a USphere component, so I'm creating it and I'm naming it collision sphere. This is now my root component, and then I set the sphere radius, and basically it's like you were working on the Unreal Editor and specifying the things by hand, like, okay, my sphere radius is this one, this is my, I want to add a new component which is a sphere component or collision sphere, so I'm doing this in C++. And now I'm setting up the collision profile to overlap all dynamic. For the mesh component, we created the uStatic mesh component, named mesh component. It is attached to our root component, which is the collision component. And we disabled collision because we just want the mesh to collide with our, let's say, collision sphere. So uSphere component, which already has the collision profile name. Finally, we bind our on component begin overlap of our collision sphere to this function, which is the on overlap begin, that we are going to implement right now. So I'm going here to implement that function. So we have it here. Okay, but there is also another thing that I want to show you, which is my tick function, and on my tick function I want to rotate continuously my static mesh. So basically the coin, not the static mesh, but the whole actor in this case. So basically what is going to happen here, my coin or collectible is going to be spinning at a given rotation speed. So the user has some visual feedback about something that can be collected because it's spinning. It's fancy stuff, it's cool. So on collision sphere, so basically for the on overlap begin of our collision component, basically what we check here is the other actor that collided or overlapped with our collision sphere. We try to cast it as a character to see if in fact is a character. If it is a player character, okay, we just log, write a log message in our log console, collected for the number of points, which is point value, and we destroy the collectible. Okay, that's it. I think everything is set up. So basically now we just need to go back to Unreal Engine. Let me move my head a little bit upwards, click compile and see. So compiling for live coding, building actions, it's compiling and everything works perfectly. As you can see, live coding completed. So yeah, we are almost done. So now we just need to create our let me close this, our blueprint that inherits that C++ class and set up the static mesh and so the point and tweak the point value. So let's do that on the next slide. So let's create our blueprint child. So basically to create our blueprint child, there are several ways to do this. Well, one way is go here on our collectible class. Here it is. Right click and say create blueprint class based on collectible, or the other way around is go, I'm used to go to here to blueprints folder to create my blueprints, right click and blueprint class, and on all classes if I type collectible, I have my class here so I can use it. Just click selectable and name this. Let me check what was the name that I gave it. So BP collectible coin. So name this class BP collectible coin. So basically this is going to be a coin that is a collectible. So if I open up this blueprint, as you can see here, I have my collision sphere, my mesh component. Their name is collision sphere mesh component, which are in fact the names that we gave here, collision sphere and mesh component. Since they are read-only, you cannot delete those here, only edit in C++. So if I try to delete, I'm not allowed to. However, here, let me check one thing to show you. Here on the source, or the other file, sorry, on the other file, we have here the point value and rotation speed. So if we go to our default values and try to type rotation speed, there is on the collectible section as we specified. So if I type collectible, we have my collectible section. Here it is with point value, rotation speed, and now you can tweak those easily. And since they were declared as collectible category, let me just do this, collectible category, they appear on that thing, and since they are added anywhere in blueprint read write, you can tweak them, you can change them. So that's the thing, you don't have the gameplay code over there on the blueprint. So if I show you the event graph, it is empty, but you will see that the gameplay works and everything is working. So basically I just need to go to my mesh component, and on my mesh component specify what is the static mesh that I want to use. I can specify, for instance, this circular glow. Let me rotate this so it's spinning, so it will be spinning like so. Compile, save, and that's it. Now what I need to do, this is so simple, you just drag this to my level, and if I click play, there it is. And let me show you something also. Let me go to the output log and dock this on layout so we can see my log message. So when I pick the coin, as you can see here, it said collected for 10 points, and the blueprint worked perfectly. Despite you go to the blueprint itself, and on event graph you don't have any code, you can also delete everything on the event graph and it will still work flawlessly, because the gameplay code is hidden, is on the C++, but is inherited on this class. So basically, yeah, you can do this, and now you can do some other thing like creating a new instance of this class and another one, and this one you can tune. So basically I can go here and type collectible and say, okay, this spins faster and has more points, 45 points, and this spins slower, let's say 45. So you can tweak each one, and only gives you 5 points. So let me now play the game, and you will see they are spinning at different speeds. On the right is much slower and gives you, as it says here, 5 points, the other one 10 points, and finally this one 45 points, as you can see here on the log. And let me show you this again. Basically, on the source file you add on the collision, writing the log, the number of the points, and destroying. So basically all this code is hidden, it works. So that's the way to do things. You should use C++ for all gameplay code, and then use a blueprint to place things on the level, tweak the values, the materials, the textures, the sounds, and that's it, nothing more. So basically that's it. I hope you liked and you enjoyed this session. So for the next steps, we are going to, you should now write gameplay logic in C++ for performance. So you learn what is the professional pattern, create blueprint children for visual assets. Now you should always place the blueprint instance in levels and never C++ classes. And as you saw, uProperty for all uObject references, and use uProperties for everything like we did here. So uProperty on the collectible, like uProperty for components, for other types of properties, so they are visible in Unreal Engine, and you can set those up. So wrapping up this, what you have learned: the essential macros, uClass, uProperty, uFunction, component-based actor architecture, collision and event handling. Most important, the C++ blueprint workflow. And now for the next video. And if you want to dive further by yourself, you could practice with more complex actor classes, explore some Unreal source code for examples, and learn about subsystems and advanced patterns. For the next video, we will talk about memory management essentials. However, I will let this info here if you want to explore by yourself until the next video is up. So I will talk about garbage collection, the key rules about smart pointers, debugging and best practices, and some performance tips. So if you have any question, please don't hesitate in comment or send me an email. My contacts are at the end of this presentation, and this presentation will also available on the link below, on the description below this video. And okay, here are the resources: Unreal Engine documentation, API, community forums, my email, course materials are available here. And that's it. Stay tuned and use Unreal Engine. Thanks guys, thanks for watching.